Hello, this is Nolan Bach, and I'm going to be demoing a launch script I wrote in Kerbal operating system to get into a circular orbit around Kerbin. Alright, so I have KOS open right now. I copied a launch script onto the onboard computer, which I have loaded above the RCS tank. And now I will run the script, and this will be the last thing that I do manually. So now we'll just be watching um, the Kerbal 1 stock plus the KOS scriptable control system pilot manually. So the first thing we'll do is orient itself east. The reason for that is because when we're doing a gravity turn, the most efficient way to do it is to gravity turn east, since the planet is spinning east, so we'll get a little assist from the momentum of the planet. My basic strategy here was to gradually pitch down from 90, so facing straight up, to 0 horizontally relative to the planet. So at about 10,000 feet, we'll be at 45 degrees, and then at 70,000 feet, we'll be at 0 degrees, and trying to get the apoapsis up to 100,000 kilometers, or sorry, 100,000 meters, 100 kilometers. Once that happens, I'll try to stabilize the orbit. Well, the operating system will try to stabilize the orbit by getting the periapsis above 70 kilometers. And then once that happens, it will circularize the orbit, getting the periapsis and apoapsis really close, probably to about 101 kilometers each. All right, so here we saw some telemetry. I think we're going to drop the solid fuel pretty soon here. Just about now. Gonna stage automatically. Yeah, there it is. And we got the telemetry back for dropping solid fuel. And now we're just on liquid fuel, getting up to 10,000 meters. Like I said, we're pitching down to 45 degrees. So the idea is that we can see a little better from this view. We're trying to get the apoapsis high enough to be outside of the atmosphere, but also initially get the path of the rocket enough out that I won't have to burn very much to get a circularized orbit. So kind of the alternative way to do this would be to fly straight up and then straight over, but that's pretty inefficient and actually won't work with the Kerbal 1 fuel system. There's not enough to keep both the periapsis and apoapsis and periapsis above 70 kilometers. So you have to get a little clever about using the gravity turn. So up here we can see a plugin, a mod called Kerbal Redux Engineer, which gives us the apoapsis height, the periapsis height, and the delta V remaining, which is the meters per second we can change the craft with the remaining fuel. So I think we're just about to stage here, and we'll see that in just a second. Yeah, there it goes, and we kicked off the second liquid fuel burn, so I can switch the view again. So now obviously we've shed like half the craft and are just moving into trying to get the apoapsis up higher. Like I said, we're still pitching down. At about 70,000 feet, we'll be at pretty low, between 10 and 0 degrees. And that's because the lift from the craft moving so quickly will pull it up to 100,000 as long as we're burning horizontally. So that part of the burn will just be to get around the planet so that we can fall around. One nice thing about this is we're in an equatorial burn just because of where we launched. So for later missions, we can pretty easily go to the Moon, which is on the equatorial plane. I'm going to warp us a little bit to get ahead to where not much interesting is happening. We're just burning at full speed. We got to get the apoapsis up to 100,000, so I'll end the warp around 90K so we can see what's going on. We can still see that we're pitching down a little bit. There we can see the trajectory of the burn. Yeah, there we go. All right, so now we're at 100,000, the apoapsis, I mean. So the next part of this is that once we want to get the periapsis to above 70 kilometers, and now it's at negative 183. So what that really means is that we're just going to crash into the planet right there. But we don't want that, and the best way to raise our periapsis is to burn prograde at the apoapsis, which will raise the periapsis the quickest. So this is the next part of the burn, which I'll fast forward to. It should only be about 2 minutes. But we'll fast forward through that a little bit. So at about 1 minute, I'll stop the warp. Yeah, there we go. All right, so now we're going to start burning a little bit pretty soon here to try to get the orbit circularized and try to get the periapsis, or sorry, not circularized yet, to try to get a stable orbit, so the periapsis above 70 kilometers. And then the onboard computer will add a maneuver node to circularize the orbit. So here we go, started the orbital burn. It's going to try to be clever about waiting until the apoapsis is close enough. So it'll take a couple tries, but basically, as soon as we get close enough, we'll start burning, and then as the apoapsis changes to further away because we're burning, we'll stop. So we can see our periapsis changing. We were at, I think, negative 183,000 meters, and now we're at negative 33,000. All right, finally, periapsis that's positive. But that's still too low, so anything under 70 kilometers will bring us into the atmosphere, slow us down, and crash us into the planet, so it's not actually a stable orbit. And so we still need to burn. Getting much closer. So here's the delta V we have so far, so this is the remaining fuel we have left to burn, which we want to try to maximize. Probably 2 more burns left until we can set our circularization maneuver node and be done and be in a circular and stable orbit. So close. 63,000. Let's try to speed this up just a second. Guess it won't let me speed up because we're getting too close to an acceleration. Yeah, there it goes. Nice. So now we're above, our periapsis is above 70 kilometers, so now we want to be in a circular orbit. And again, the way to do that is to burn exactly at the apoapsis, raising the periapsis until it equals the apoapsis height. So our new target apoapsis will be 102 kilometers, and 102 kilometers separated by 462 meters by about 50 meters, which is pretty close. So we have 30 seconds until that burn. It will try to equalize the execution of the burn evenly on both sides of this, but since it's just a short burn, it'll be really hard to see. It'll basically, as the clock strikes 0, it will start the burn and then slow it down to try to get 25 meters per second added to the orbital velocity. And then we'll be done. So we see the estimate of the burn duration, the node thing, the node timing, the ETA to it. Here we go. Awesome. Okay, cool. So we overshot a little bit in our burn. So it wasn't 50 meters apart. This one's about 200 meters apart, but still really close. And so now we're in a stable and circularized burn with 547 meters per second delta V left. And there you can see the program ended. That's how much we overshot by. All right, so that's it. Thanks.